Assalamualaikum and good morning to everyone. I'm from IED Principle Section 2 from Group 2, and I want to present to you about the Popiah spray roll machine. Okay, I am Muhammad Muzamil Ralibi, and I would like to talk about the problem statement and the cause of the problem. Okay, let's move to the problem statement. As you can see, the manufacturers of the Popiah made the Popiah by manually. So the fillings of the Popiah will be not same, and the size will be different. And the second problem is that the production of the Popiah will become limited because the Popiah company use the human workers to make the Popiah. So let's move to the cause of the problem. The cause of the problem is who needs this machine? The manufacturer of the Popiah needs this machine. For what? This machine is a semi-automatic machine that can produce to increase the production of the Popiah and to control the quality of the size and mass of the Popiah. So why use this machine? As you can see, to maintain the weight and size of the Popiah, and the second one is to help Popiah manufacturer to roll the Popiah automatically.
Assalamualaikum, I am Muhammad Ikram and I'm from Group 2. Next, I will present about the requirement of the machine. The first requirement of the machine is mechanism that can fill and roll the Popiah spring roll automatically. Second requirement is to design suitable mechanism for efficient operation in weighting and sizing. Next, involve multidisciplinary field of study. And last is able to lift each of the Popiah spring roll scheme. Okay, for the flow production of the Popiah, at first the skin of the Popiah will located at the starting point in the mechanism, and then when we press the push button, the conveyor will be operated and the IR sensor will detect the present skin of the Popiah. When IR sensor detect the present skin of the Popiah, the shrink mechanical will operate it and sub the spring roll skin and place it on the conveyor to the next mechanism. Next, the IR sensor will detect the presence of spring roll skin, and the mechanical part for the fill and spring roll ingredient will be operated. When the mechanical part for the filling spring roll finish, the spring roll on the conveyor will be stuck at the field mechanical and begin to roll halfway. Then the IR sensor at the flipper will detect the presence of spring roll skin. Then the right side flip mechanical will be operated, and next the IR sensor will detect the presence of spring roll skin, and then the left side flip mechanical will be operated. And lastly, the operation of Popiah skin is the spring roll will go through the mechanical part that have some blunt tip to roll the spring roll completely. Okay, for our sketch of idea from the other desk, the first one is the shrink mechanism. It is used to move the Popiah skin to the conveyor. The next one is the filling of ingredient of the Popiah, and then this one is to flip in front of the Popiah skin, roll it halfway, and then another mechanism is to flip the right side and left side of the Popiah skin. And then the last one is the mechanism that used to roll the roll the Popiah completely. So this one is the complete of our mechanism.
My name is Muhammad Hadri from Group 2. I'm gonna present you about My name is Muhammad Hadri bin Mokhtar. I'm gonna present you about the decision matrix. Decision matrix is used to select which is the best solution for the problem statement. So we choose the first solution out of 4 solutions. Because for the first point is about the mechanism that can fill and roll the Popiah spring roll automatically. We give a 3 point for the first solution and 2 points for the other solution. The second one, which is the design suitable to counter the problem. So here, the first solution and the second solution have a good design to counter the solution. So we give a 2 point from that for that, and the third and the fourth get a 1 point only. So for the third, is involve multidisciplinary, which is use many field of study in the solution. So we choose the first solution because in this solution we use programming, we use electrical, we use mechanism, we use mechanical. So for the fourth one, we is able to lift up each of the Popiah spring roll scheme. Here at our design later, we can see that the first solution has the best way to lift up the Popiah scheme. Next, we talk about the safety. The safety for the first solution is better than the others. Then we got the environment friendly. For the first solution is the most environment friendly method. And we talk about the cost effective. Cost effective for the first solution, the cost used is less than the other solution, and the quality of the solution is better, the low cost and better quality. And for the C4, we talk about the easy maintenance. For all of the design have an easy maintenance because the design is just open design, so easy for maintenance. For the C5, we talk about the elegant. The first and the second solution have an elegant design. Otherwise, where the third and the fourth have less elegant. So we talk about the robustness. We choose the first solution because the material we use in the first solution is tougher, is better than the other. So for the C7, for the last is a reduced time. All of the solution can reduce time to make the Popiah roll spring. See, next we will go to the mechanical design. So this is an exploded view for our mechanical design. Okay, first we will see at the first. It have 4 main part, which is the vacuum part, filling part, flipping part, side flipping part, and the roller. Okay, first we will see at the base of the conveyor. We use the conveyor, so we will see at the base conveyor. There's the conveyor is about 150 cm, which is 1.5 meter. So we have a conveyor belt and one motor to move the belt. We go to the first main part, which is the vacuum part. So if we zoom there, we can see there's 2 motor, which is at the conveyor, the small conveyor one, to move the shrink forward and backward. And for the second motor, we use at the shrink itself for the shrink to suck and release the Popiah skin. And then we go to the second main part, which is the filling part, the yellow one. As you can see, there's 2 yellow colors. So the first, the big one is used to fill the filling, which is a mushroom, the mushroom filling in that container. So there is one motor there to compress the fill, to push the mushroom go up to the cylinder hole. Okay, next you can see the yellow one, the smaller one. There is a cylinder hole, which is if you fill the creamy mushroom inside the hole, inside the cylinder hole, so it will have a 50 gram and a cylinder shape of filling. So the motor is used to move the cylinder hole forward and backward to fill out, to push out the creamy mushroom from the cylinder hole, to place the filling on the skin of Popiah. Okay, next we will move to the next main part, which is the flipper. The flipper consists of the stand and the flipper. The flipper can rotate about 90 degrees so that the Popiah can be flipped into half to cover the filling. And then next we will go to the next main part, which is the side flipper. There is two side flipper which are on the right and on the left. This side flipper consists of one motor and a plate. The motor can move the plate about 120 degrees to flip the side of the Popiah. So first we will flip the right side of the Popiah, and then we move to the second side flipper that will flip the left side of the Popiah. Okay, next we will move to the next main part, which is the conveyor will move the Popiah to the roller. This roller consists of the stand and a plate that have a blunt tip that it can roll the Popiah completely. So then the process will finish after the Popiah have through the roller. Okay, the next slide is about the mechanical drawing, which is show the detail of the design with the dimension of each part. If you zoom there, you can see the diameter, the length, the width of the part for the design.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Nurrahman Putra. I'm from Group 2, represent the electrical part. First, we use MCCB 10 ohms and the DC supply, which is AC convert to DC. And we use 6 input. We have 2 push button, first stop and start button. And we use 4 IR sensor, which is the input for us for that. And then we use 9 output. We have 4 DC motor, 2 which is 24 volt and 4 and the other 4 which is 12 volt. And then we have 2 servo motor at the feed part, and we have a stepper motor at the shrink part. Okay, for the material cost. For the material cost, we use one MCCB, which costs 45 ringgit. The DC supply, which costs 90 ringgit. We use one DC supply. For the push button, we use 2 push button, which costs 5 ringgit. And the IR sensor for the input, we use 4 IR sensor, which costs 40 ringgit. And we use DC relay, which costs 90 ringgit. We use 6 DC relay. Okay, for the DC motor, we have 2 types of DC motor. For DC motor, which is 12 volt, you can see 150 RPM, which costs 180 ringgit. And the other 2 is 24 volt, 2600 RPM, because 300 ringgit. And we use 2 servo motor for the part of the feed, which costs 60 ringgit. And the stepper motor for the shrink part, which costs 15 ringgit. And our controller we use PLC. For the PLC we cost the 1,200 ringgit. Okay, I proceed for the mechanical part. We use 4 roller. The 4 roller which cost the 80 ringgit, and one bed for the conveyor which cost the 40 ringgit. 5 aluminum plate, 250 ringgit, and 1 plate for base construction, which cost 135 ringgit. And our total up for all the cost, the price is 2,555 ringgit. Okay, that's all for me.